Hey everyone, welcome back. In this video, we are going to cover the inverse trig integral formulas that you'll need to know for your AP Calc exam. So there are three main formulas that you need to know. The first one is the inverse sine formula there at the top. The second one is the arctan formula or the inverse tangent formula. And then finally, we have the arcsecant or inverse secant formula. So basically, first, let's just go over these formulas and what you want to look for. So here, what I'm noticing is I have a difference of squares, right? So I have a squared and u squared, and then I have a minus sign in the middle. So that's why that's called a difference of squares. And then all of that is within the square root symbol. So then basically, if I have that, that is going to be equal to the arcsine of u over a. It is important to be able to identify a because sometimes you won't be given a directly, like this entire term might be 100 as an example, and you have to recognize that a then is equal to 10. We'll talk about that more in the second part where we actually go through examples. So next, if we do inverse tan or arctan problems, this is a little more simple, but pretty similar to this formula here. Now we have a sum of squares, right? Now we have plus, but again, we have the same idea where we have a squared and u squared there. Again, this is going to be equal to 1 over a, arctan of u over a, so you will have to be able to identify a when given a squared. And then the third formula is probably the most complicated. This is the arcsecant formula. And you can see here it's 1 over the absolute value of u times the square root of u squared minus a squared. So again, here we have this difference of squares underneath a square root sign, which is very similar to this arcsine formula up here. And that is going to be equal to 1 over a arcsecant of the absolute value of u over a plus c. Okay, those look very complicated, so let's go ahead and look at a couple of examples. Before we get there, a couple important notes that I forgot. You will oftentimes have to use u substitution and other algebraic methods of factoring when you're given these types of problems. So you want to pay really close attention to a and u, which I kind of already hinted at before. And then one other thing to note is that technically you do have these other integrals for arc cosine, arc cotangent, and arc cosecant. But since they are related to these three main ones and are just offset by pi over 2, you really aren't going to see those nearly as often, if at all. Okay, so now let's go ahead and jump right into some examples. So here is a pretty classic example. Let's say we're looking at the integral of 1 over the square root of 9 minus x squared. So again, what am I thinking of? I'm thinking of, okay, well, I see a square root sign, right? And I see that I have a difference of squares here. Next, I'm going to identify this as basically what a is equal to, which is going to be the square root of that. So in this case, my a is going to equal 3. And then using the same variables I did in my formula above, my u would equal x. Then I'm going to just plug it into my formula, and I would get arcsine of x over 3 plus c. So it's actually not that bad. I think the hardest part of these problems is identifying that one, which formula to use, identifying this as an arcsine integral, and then two, being able to identify what a is and just not making a silly mistake there. All right, moving on. Okay, so in this case, pretty classic example here, the integral of 1 over 4 plus x squared. Again, what am I looking for? Well, I'm identifying this denominator as a sum of squares, where 4 is 2 squared. So then that's going to tell me that this is going to equal arctan. And then I'm going to go ahead and plug in my a value of 2 here and here, and I'm going to plug in my quote-unquote u value of x there. All right, and then let's move on to our final example. This one is the integral of 1 over the absolute value of x times the square root of x squared minus 16. So again, what am I noticing? Well, I'm noticing I have a square root in my denominator, and then within that square root, I have a difference of squares, right? X squared minus 16, where 16 is 4 squared. And then in front of that, I have it multiplied by the absolute value of x. So in order to do this, basically I'm going to identify my a as the square root of 16, which is just 4, and then I'm going to plug everything in. So then I get 1/4 arcsecant of the absolute value of x over 4 plus c.